Earthquakes are sudden, violent shakes of the ground, caused by the immense pressure deep within the Earth. Tectonic plates are massive slabs of rock that make up the planet's outer shell. They move slowly. When these plates grind against each other, they can get stuck. Pressure builds up over many years, sometimes centuries. When the pressure finally becomes too great, the rocks suddenly break and slip along a fault line. That abrupt release sends out seismic waves in all directions. Think ripples from a stone thrown into a pond. Those waves travel through the Earth and make the surface shake, sometimes with devastating force. India is particularly vulnerable. The country's geography is shaped by the collision of the Indian plate with the Eurasian plate. That tectonic crash created the Himalayan mountain range, one of the most seismically active regions in the world. Large parts of India are classified as high risk. Authorities use seismic zone maps to manage the threat. During an earthquake, the complex web of infrastructure that supports a modern city is the first thing to break. The most immediate and visible failures occur in buildings. Structures not designed to withstand lateral or sideways shaking are extremely vulnerable. Unreinforced brick walls can crack and crumble within seconds. Unreinforced concrete block walls can crack and crumble within seconds. Vertical supports, such as columns, can buckle under stress. Columns buckling can cause a catastrophic pancake collapse. Floors fall one on top of another. This is particularly deadly. Leaves few survivable voids makes rescue operations extremely difficult. In dense urban areas, one collapse can trigger neighbors to fall, creating a cascade of destruction. The earthquake that struck the Kutch district of Gujarat on January 26, 2001, serves as a powerful and sobering case study. With a magnitude of 7.7, the quake unleashed immense destructive force with its epicenter near the town of Bhuj. The city and surrounding areas were devastated. The shaking reduced thousands of buildings to rubble, including multi-story apartment blocks, hospitals, schools. The official death toll exceeded 20,000 people, with hundreds of thousands more left injured and homeless. The damage was a direct result of widespread roads. Roads were fractured and blocked by debris, preventing aid from reaching the city for crucial hours and days. However, the story of Bhuj is also one of remarkable recovery. New codes, wider roads, safer public spaces, and reconstruction that built back better. The core principle of earthquake-resistant design is not to create a building that will be completely undamaged, but to create one that will not collapse and will protect the lives of the people inside. Engineers have developed several ingenious methods to achieve this goal. One of the most effective techniques is known as base isolation. In this system, the building's foundation is separated from the ground by flexible bearings or pads made from layers of steel and rubber. When an earthquake occurs, the ground can move violently back and forth, but these isolators absorb much of the seismic energy. The building above sways gently instead of shaking destructively. This is like putting the building on roller skates to let the ground move beneath it without transferring the full force. Another fundamental strategy involves strengthening the building's structural skeleton. This is often done using shear walls, which are very stiff vertical walls made of reinforced concrete. These walls are strategically placed within a building's layout to brace it against the horizontal forces of an earthquake. They act like the hard spine of the structure, preventing it from twisting or deforming dangerously during a tremor. In addition to shear walls, engineers design buildings with ductile frames made of steel or specially reinforced concrete. Ductility is the ability of a material to bend and stretch without breaking. Retrofitting older buildings, adding braces, column jackets, and wall ties is essential to reduce risk. Creating earthquake-resilient cities requires a two-pronged approach that combines decisive action by authorities with proactive preparation by citizens. For city and state governments, the first step is the strict enforcement of seismic building codes, inspections, accountability. For older, vulnerable buildings, cities must develop and fund large-scale retrofitting programs, prioritize hospitals, schools, fire stations, Urban planners should use seismic risk maps to guide land use decisions. Restrict unstable slopes and liquefaction zones. Create more open green spaces for safe assembly points. City authorities must invest in the resilience of infrastructure networks. Upgrade brittle pipelines with flexible materials. Inspect and retrofit key bridges and overpasses to keep transportation arteries open. Every city needs a comprehensive, well-rehearsed disaster management plan. Clear protocols for search and rescue, emergency medical facilities, and distribution of essentials, water, food, medicine. Every household should prepare, drop, cover, hold on, and build a 3-day emergency kit. Through smart engineering, robust public policy, and dedicated community action, we can move our cities from high risk to true resilience.